Alright, in this video, we're going to see how on and off delay timers work. Then we'll do a simple project, to use these timers in a line production. Before we get started with today's video, I just wanted to inform you about all the great content I have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's start with on delay timer. This is on delay timer symbol in ladder language. We can notice this timer with a small syntax TON. This instruction is used to set an output to on after the preset time. Here, the preset time is 5 seconds. This timer has two inputs which are start input and preset time. And this is the maximum time which can be entered, like pulse timer. Also this timer need a data block to work correctly. And have two outputs. Now let's see what is this timer and how does it work in S7-1200. When the RLO at the start input change to 1, this timer start its work. After preset time, here, when the elapsed time at ET output reach to 5 seconds, the output of this timer will be on. If the input signal change to 0, output will be off. Now, see here, if the start input goes to 1 and come back to 0, before ET output reach to preset time value, the output will remain off. For example, if we have a pulse for 2 seconds, which is less than preset time, the output will be off. Now, let's do an exercise. Try to write a program which with a push button, first turn an alarm siren for 5 seconds, and turn on an alarm light, then turn on a motor. Here we have a push button and 3 outputs. A motor, an alarm light and an alarm siren. Well, if the push button is pressed, the alarm siren must be on for 5 seconds, so I need a pulse timer which has been told in previous video. Let's see the PLC wiring. The siren is connected to Q0.2. So I enter it here. I want to turn on alarm light immediately after the push button is pressed. So I connect alarm light output to input contact, without any timer. Its address is Q0.1. Finally, the motor must be on after 5 seconds. Here I have a delay to start motor. So I need an on delay timer. As you see, in the PLC wiring, the motor is connected to Q0.0. Alright, this program is complete. Here I have an opened virtual PLC. Let me transfer this program. To test, I use Factory I/O. It's expected you can design this plant, otherwise please review previous videos. As you have seen before, here, I can connect Factory I/O devices to my PLC. Now let's test the program. As you see, when I press this push button and hold it, first the alarm siren and light start are turned on. After 5 seconds, the alarm siren will be off and the conveyor motor start to move boxes. Also, you can see state of outputs in TIA software. First output is alarm siren, then alarm light, and finally, conveyor motor. Similarly, I can test this program with my PLC. I've explained its necessary settings before. Here, the first 3 outputs are used to turn on the conveyor motor, alarm light, and alarm siren in Factory I/O. Now, let's see another timer. Off delay timer. This instruction is used to turn off an output after the preset time. The ladder symbol of this timer is like previous. We can notice this timer with a small syntax TOF. Now see this diagram. When the start input goes to 1, the output start immediately. But when the start input back to 0, the output will be off after the preset time. Here, when the start input goes to 0, the elapsed time output, start from 0 to 5 seconds, after that, the output will be off. Pay attention here. When the start input goes to 0 and before the ET output reach to preset time, the start input goes to 1 again, the output will remain 1. OK, this timer turn off its output, when the ET output reach to preset time after the last negative pulse at start input. Let's write a simple program with off delay timer. See this PLC wiring. Here we have two outputs. I want to write a program to turn on a motor and fan. When the motor is stopped, the fan will be on for 1 minute. Well, before any exercise, pause the video and try to do that by yourself. Then compare your program with mine. Alright. I have two push buttons. I don't want press and hold a push button, like previous exercise. So I use a SR flip-flop to hold the start and stop request in a bit memory. This bit will be used to turn on our outputs in the next network. Pay attention, because my stop push button is normally close. Here, I use a normally close contact. Otherwise my program won't work correctly. As you know, the SR flip-flop need a bit memory to work correctly. Also I will use this bit memory to start and stop our outputs, so let me to define a appropriated tag for this bit memory. Also we can write appropriated name for each network. This makes to have a better program. Based on this wiring, motor and fan are connected to Q0.0 and Q0.2 addresses. I want to start and stop the conveyor motor, immediately after I press start and stop push buttons. So I just need connect motor output to start stop bit memory, which has been defined in the first network. I want the start-stop contact, turn on and off the fan like the motor, but when the motor is stopped, the fan will be stopped after a delay. So before fan output, I need to insert an off delay timer in my program. Here, I need 1 minute delay to turn the fan off. Well, this program is complete. Here I have an opened virtual PLC. First I reset the CPU with click on MRES. Now let me transfer the program and test it in TIA software. Now I change this normally closed contact. Now let me activate start contact. As you see, both outputs are on. Now if I change stop contact, it makes turn the motor off immediately, but the fan is still on. It will be off after 1 minute. Alright, in next video, we're going to do a simple project, to see how a line production start and stop, and also use on and off delay timers together. After that we'll continue learning other timer operations. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.